Picking up where we left off now in part 2, let's start to solve this. Log base 10. Now notice we had one like this earlier where this is going to be 2 to the third power. So this is going to be log base 10 of 2. And again, where do we put that 3? Out in front. So keep in mind this is actually 3 times this. And that's from our power rule where we had x to the second raised to the third. We multiplied. So with this exponent, by moving it to the front, we can multiply this. All right, let's go on. There's 2 to the third, and we're going to move the 3 out in front. And if we had this, then we're going to multiply this 3 times this value to get this. Okay. Now, as you probably imagine, this is done in a very similar way. So it would be log base 10, and this is going to be 5 to the second power. So when we write it, it's log base 10 to the fifth. We're going to take that exponent and move it out here in front, so that when we do this, we're going to multiply this by 2, and we'll see it in action now. Again, these slides are well done. I like them. So there's the 2, and then we put this in our calculator and multiply by 2, and we get this as an answer. Okay. So again, some summaries of properties of logarithms, and we just worked with the product rule. You might want to add, I think it's number 5 now that we're going to add. You can pause it, but we'll go on. And there is the quotient rule. The other one was the product rule. And there's the power rule here, where we take the exponent because we're multiplying. Here, since we're dividing, we're subtracting. Okay. Now, for example 5, and again, be writing the example numbers down in your notes. We want to expand. So let's see what we have here. Well, log base b of 2. Remember, this is multiplication, so we're going to add log base b of x, and then where do we put the exponent? Out here in front as we multiply. Now we don't put that dot there, but you have to be careful that you don't mix up the 3 with the L. That's not a 1 there. And there it is. So it almost looks like a 31, but that's the word log. You got to be careful of that. All right, let's work on this one. And again, you can always pause and try things on your own. So this will be log base b. We're going to do this x first. X. Plus, since this is multiplication here, log base b of y, and I have to stick in this exponent in front here. So let me just stick it right in there. And this is then division. So we go minus, for the division part of this, log base b of z. And again, if you know the rules, it's really easy. But remember, a little later we're going to be taking this, and we have to convert it back to this. So this way maybe is a little easier, but actually they're easy both ways, or depending what you're doing. So they're putting this together at first, and now they have to take that 2 and put it out in front of the log there. Okay, there you go. We did it in one swoop here. Alright, how about this one? Now notice we have a negative exponent. That's not a big deal. So this is going to be log base b of our x and plus log base b of our y. But now we have to put a parentheses around this because we have to take this exponent and put it out in front. All right, let's take a look. And I see they are taking it a step further, distributing this -3 to each of these terms, which is okay as well. So be sure you get this last line here. I didn't quite do this last line. All right. All right, let's do this one here. So this is going to be log base b, and we're going to convert this radical sign, and we need to put that in parentheses to the 1/2 power. So this is going to be very similar to what we had before. Log base b of 3 plus log base b of x, all of this in a parenthesis, and we move the exponent out here to the front. And then we get rid of our parentheses by putting it here 1/2 log base b of 3 plus, again we're multiplying, 1/2 log base b of x. Now, by the way, if you put this in MATLAB, and, you know, they wanted this, you would get lots of partial credit for this step. But by doing the practice and the certify, you're seeing what they want the answers as. Okay, we converted the radical to the 1/2. Put that out here. They're adding a little extra rule, or an extra line, and there's your answer. Okay, now this is in its expanded form. They want you to convert this to the more simplified or condensed form. Let's get a little darker color here too. Okay. So what do we have here? Well, we know we're going to take this exponent from in front and put it by the x. So we have log base b x to the second, taking this exponent and putting it to the power of x. And the minus, we could put the minus here, but we know the minus is going to go down to our denominator here. This is going to be log base b of y, and this is going to be to the third power. So we can simplify that a little bit by saying log base b of x squared over y cubed. That looks good. Okay, they're putting the exponent by the x and the exponent by the y. This is like an extra step. I already moved that down below. Okay, they're leaving out one of the steps that I had, but the answer is the same. Okay, that was example 6, letter A. All right, let's take a look at this here. If you're starting to catch on, there may be some shortcuts you can make. For instance, this top part is log base A, and this 1/2 is going to be, let's put it there, 4 to the 1/2. But actually, 4 to the 1/2, this is just going to become a 2 if we simplify that. So let's erase that. See if we can save ourselves a little bit of room. As long as you know where it's coming from. This is going to be 2. And both of these now we know are going to be down in the denominator here as log base A of 5. And this is going to be log base A of y, so this is just going to be a y here. And we're going to simplify this. Log base A, and this is going to be just 2 over 5y. Okay. I think that'll work. So they're converting the 1/2 to the exponent of the 4 right there. They only did one little change there. And then they're taking the square root of 4 to get the 2. And these are going to go down into the denominator as they combine these two. And this is what they're ending up with. So, Now you might say, do they need these parentheses here? I think you could get by without them, but, by putting in parentheses, that doesn't hurt. All right, let's go on. Okay, how about this one now? Getting a little more challenging. This will be the log, base A, and since we're adding, both of these go up here. And I don't know if you note what these are. These are conjugates. So we can actually simplify that. So this is log base A of x squared minus 1. And I believe you could put those in parentheses too. All right. Let's check this out. So they're putting them together and then showing that these conjugates can be multiplied and you get the difference of perfect squares. All right, that's good. Okay, let's work on letter D here. We might note the instructions that they're giving write as a single logarithmic expression. This is example D. So we're going to start as log base B, converting this radical to its fractional exponent, plus log base B of x to the 1/3, and now we're going to move the exponent 1/2 log base B of x plus 1/3 log base B of x. And now we can actually factor out these two parts here. So we get 1/2, and this is going to be added together 1/3 the log base B of x. Now we have to add our two fractions, and I'll change colors for that, to make a common denominator here of 6. I need to multiply this by 1 in the form of 3/3, and this by a 1 in the form of 2/2. This is going way back here. So this is 2 log base B of x. So this becomes 5/6 log base B of x. And this is one way to do it. Another way would have been to add these exponents up here and then move it to the front. And they'll show you that way too. We're getting to another 20 minutes here, but we're almost finished now. So this is the way we did it. and we got our common denominator, and they're working it out for you on the side. Now, it also could have been done this way, where you bring these two together and then add your exponents this way, and then move that to the front. So either way, it works out for you. Now, before we complete this, you want to be super careful that here, if you were to see something like this, this cannot be simplified, because this is addition. We can only simplify when it's multiplication, and we show it by addition, but this cannot be simplified, nor can subtraction in this form be simplified. And they're showing that. Okay, there are a few problems, but we are at 21 minutes again. So if you want to pause, look at these, and then there are the answers. All right, 2 more sections in Chapter 10.